Hey there guys, Mike here again. Thanks for clicking this video. Welcome to my shop. In a previous video, I made this 12 AU7 line stage. Preamp here is part of my new shop stereo system that I'm building, and I made it look like this old military device to kind of give it a rough and tough look. I like this look a lot. I've decided I'm going to make a matching power amp to go with this as well. So with this amplifier, I'm going to do something a little different. Since I have a small space here, I don't need a lot of power, and I want something that's high quality, and I want a tube that's inexpensive and will last for a long time. So these TV tubes here, a 6D N7 tube is a perfect candidate for it. So these tubes are actually used for the oscillator and the vertical detection of the television set, and they're really unique because they have a dissimilar triode. So the one section of this triode is similar to a 6SN7 tube, so one half of a 6SN7 tube, and the other section of this triode is similar to a 45 tube that can dissipate up to 10 watts. So this would be a perfect candidate for a little flea-powered single-ended triode amplifier. So what I'm going to do is do a whole build document of this as well, and I'll link it in the description below, and I'm going to make the chassis to look similar to this as well, just a little bigger. Stick around and we'll go through the whole process of making this cool little amplifier. Well, I did up an initial schematic for this amplifier design. It's just your basic two-stage amplifier with an input tube and a power tube. I don't know what the ending values are going to be yet, but I have the tubes and are roughly in the operating parameters which I feel they should be in. So once we build it, we will measure everything. We'll measure the voltages, we'll measure all the resistance, and we'll tweak and adjust things as necessary. And once it's finalized and I'm happy with it, I'll record it all and I'll put it in a proper document and link it below. So let's go ahead and review the schematic. From the power transformer, 120 volts in, we're going to leave with 275 volt AC out. We're going to go with a solid state bridge rectifier here, and that should give us about 380 volts DC. So leaving the bridge rectifier, we go to our power supply unit here, and this is the filter section that helps get rid of the ripple off the full wave bridge rectifier. This filter cap section is going to be shared between both channels. For the heater or filament circuit, we're going to go with a DC rectification. So I have 4 Schottky diodes, so these are 40 volt 3 amp diodes. We'll also need a dropping resistor here so we can get that down to about 6.2 to 6.3 volts. So at a high level, I'll show you this works. So the unamplified music from the source comes into the pin 4. It then gets amplified and goes to the plate. So the AC signal is riding on the DC. It goes through the coupling capacitor. So the way the coupling capacitor works is that it blocks any of the DC but allows the amplified AC to go through it. Then it goes through to the power section, pin 1. It gets amplified even more, and the AC signal rides on the DC through the output transformer. So the way the output transformer works is we have a primary side, which is high voltage, low current, and it induces onto the secondary side, which produces low voltage, high current, and that's what drives the speakers. These tubes are actually quite robust. They're designed for a television set to work day in and day out for years at a time. I'm just going to do it in an audio circuit, and I'm going to probably push it around 7 or 8 watts of dissipation. The claim data says they can do up to 10, and that's quite a bit for this little tube. So if you decide to build a circuit, just make sure you're within that realm and it should be fine. I've heard some grumblings that the 6D N7 tube is getting a little tough to find these days, but fortunately the 6FJ7 is readily available and it will work on the circuit as well. The only issue is that it uses a different tube socket, a 12 pin, and it's called a compactron, whereas the 6D N7 uses an 8 pin. So the power transformer, I'm using this Hammond style 120 volt input with about 275 volt AC output. And for the output transformers, I managed to score these vintage style 5K primary with a 4 and 8 ohm tap, and these are single-ended transformers series feed. If you can't find something like this, Hammond makes of a multi-tap transformer that would work well in this, and it's called a Hammond BSE. So similar to my preamp build, we're going to mock up the chassis using some foam board and some poster board and a hot glue gun. We'll see how all the components interplay with each other and start fabricating. So we got the mock-up all done, and yes, it looks kind of crude like the preamplifier build, but it pretty much gets the point across on how everything's going to be situated. The front panel will just have on and off, a fuse holder and indicator, and then the inside will just mount everything on a plate here. So this will be the PT and the OT and the tubes. And then the neat thing about it is we can turn it upside down to work on it if we need to. And on the back, we'll just have our in and outs and our AC lines coming in. And what I envisioned what will happen is the front and back will all be situated to each other, and we'll do a one-piece cover and top. So we'll just slide right off and we can work on it. So let's itemize everything and go get the metal that we need. So I just made a quick trip to the metal store, and they have a crop bin, and I rummaged through the crop bin and they had exactly what I needed for the exoskeleton, so I saved some money there. From our mock-up, I made them a cut list, and they went ahead and sheared all the metal for me, so therefore it makes for perfect perpendicular cuts, and I have to worry about a zip disc or trying to make a nice clean cut with a hacksaw. For the front faceplate, I'm going to go with the 12 gauge aluminum, make it nice and rigid. For the component plate, I'm going to go with the 14 gauge aluminum, and that will make it easier to punch all the holes out. For the rear, we're going to make it out of 16 gauge steel, and I'm going to weld the exoskeleton to this to make it nice and rigid. And for the side plates, I actually got 3 separate sides. So this is the top and sides. I don't have a metal brake, so what I'm going to do is just weld this together, and this will come off as one piece. It's 1/2 inch steel angle, and it's going to go right in there, and we'll just weld that all into place, and we'll drill and tap some holes to mount the faceplate. And for the top section here, I'm going to go with this aluminum square bar, and we'll drill and tap the holes, and we'll just mount them in there. We can bolt them into place, and then the cover will slide over top of this and make it nice and rigid. So the fabrication work for the outside carcass is pretty much completed. I still have to do all the finishing of it, mind you. I have the control panel in, I put an ammeter gauge in, we have all the vent holes for the tube sockets and power transformer. Everything is done there. So this part of the build is complete. Now we have to move on to doing the component tray. So we're going to mimic this onto this aluminum, and this will sit inside there. One thing I should point out to you guys, you don't need a lot of fancy tools to build this amplifier. You can get by with getting a piece of aluminum sheared up for you and mounted on this wood base like this. I've built many amplifiers like this, and you don't need a lot of fancy tools. You can get by with just a set of drills, one of these step bits to punch out the larger holes, a drill and a saw, and you can go ahead and build this amplifier. So as I mentioned, I'll be linking the description below of the schematic and the layout, and you can follow along and build something like this. And if you want to try something more challenging, go ahead, build something like this military style cabinet. So to complete the chassis, we're going to do some stenciling now, and to create some uniformity between the preamp and the power amp, I'm going to mimic the stenciling that we have here. So to make the vinyl stencils, I'm going to use my Cricut Joy vinyl cutter. Now in my previous preamp video, I show you all the steps on how this is accomplished. So we'll just set this up and we'll go through the motions. Well, the outside carcass is pretty much complete. I just need to let the paint cure and then I can mount all the components to it. I like the way it turned out. It looks pretty cool. So the next part of the process is to actually mount the components here on the plate. So what we'll do is we'll transpose this information onto the plate. We will drill and punch all the holes out, mount the components, and actually start wiring up the amplifier. So if you like this video, please give it a thumbs up. It helps promote it. And if you like my content, please consider subscribing. It helps promote my channel and I can do more projects like this. So the tool I just used is called the chassis punch, and I have two of them. I have one to do a 9-pin and I have this one to do the 8-pin. It basically is a thread and has two teeth on it, and it pulls it through and it creates this donut here like this, nice crisp clean cut. Now if you didn't have any chassis punches, you could use a step bit like this as well. These come in different sizes. You can get quite big ones and they're quite handy, and you could do all your holes with this one little bit. Now just remember, these things tend to grab the metal really hard, so I like to use some gloves just in case it spins around and you don't want to get cut. So now that the outside carcass is pretty much complete and we're waiting for the paint to cure, we can start working on the amplifier here. So I went ahead and I punched out all the holes and mounted all the components, and I started working on the power supply and all the grounding assembly. So I'm scratch building an amplifier. This is typically the steps I like to take. We mounted all the major components. So we have our power transformer, we have our output transformers on the other side with grommets that pass through, so no sharp edges for wires to catch on. We have our terminal strips and tube sockets. Everything is mounted with stainless steel hardware with lock washers or star washers. So the output transformers and the power transformers and the safety ground, and this will wire into the AC plug, is all bonded together, and it just has onto each stud of the frame. So if there's a fault or anything like that, it all bonds together nicely and it keeps it on the same ground potential, and it will have a direct path to the safety ground. So once that's all completed, we went ahead and populated the power supply. So this is the filter cap section. We have our incoming full wave bridge rectifier there and our first set of filter caps. And I just follow the same layout as the schematic I drew up, and it makes it easy to debug, wire, and measure all the voltages or filament supply. So here's our dropping resistor, our filter cap, our Schottky diodes, and then I have shielded cables going to pin 7, 8. And with the shielded cables, you only bond the shield on one side, and I have it on that stud right there. So this whole filament supply is away from the rest of the amplifier, so it doesn't induce anything, and I don't get any noise on the filament supply, and vice versa. So at this stage of the build, just to quickly go through and check the resistance values and connectivity of everything that we've done so far. So the first step of the actual amplifier build is pretty much completed. So what's left to do now is actually mount the resistors and capacitors. I got it temporarily mounted in this little wooden chassis here so I can actually get at everything and mount these little resistors. Once that's all done, then we'll transfer this over to the actual chassis. We'll hook up all the speaker connections, the AC connections, the incoming signal connections, and then we can start doing some testing. So this part of the amplifier is completed and ready to mount into the chassis. It came together pretty good. I have the B+ intercept here for the current meter, so it'll tell you how much current the amplifier is drawing. I ended up mounting the coupling capacitors on this little platform to keep it away from everything. They're quite big, and these are oil and film capacitors. They don't like a lot of heat, so mounting it away from everything turned out pretty good. I'm really happy with that setup. I got some shielded cable for the inputs, and it's important to have shielded cable, so I got this section of shielded cable. It has 2 strands in it and a ground. I use that to shield all the inputs because it can induce noise into the system. And for the cathode resistors, I mounted them away from the tube sockets, and I have little vent holes underneath here, and if I ever need to change the bias, it makes it really easy to get at to swap out. So this is a really good method for changing your bias and changing your dissipation on the amplifier. So here's the completed amplifier chassis. Turned out pretty good. It matches the preamplifier chassis that I previously built. Stenciling turned out really good, and I added some extra vent slots there for the tubes, so you can kind of see it a little bit and add some extra venting, and that was quite easily done. It was just a mill end and my handheld router at the slowest setting. So the amplifier fits perfectly, like a glove. Almost like it was meant to be. I honestly thought I might have to move some stuff around, but I didn't. So last bit of wiring here, we did the input jacks with the grounding resistors, we did the speaker connections here, ran that through, and now we're just doing the AC mains in. So we're ready to fire up the amplifier here. All the wiring is done, all the resistance is all checked out, everything kind of matches the layout here and the schematic, all the pin numbers match, so we're good to go there. We're going to plug it into the current sink here, so the amplifier goes into here, this goes into the wall. If you turn on the amplifier and this lights up, that means you're drawing too much current or you have a direct short, so turn it off. If it stays off, then you're good to go, and we'll continue on measuring and testing everything and eventually listen. So another thing I should mention, if you have to do some alterations to the amplifier after it's been fired up, do yourself a favor and get one of these capacitor discharge tools. It discharges the capacitors really quickly. Yes, the circuit does have a bleeder resistor, but it typically takes about 30 seconds to a minute for the voltage to dissipate. This will do it in a couple seconds. So when I fire up the amplifier for the first time, I like to check the filament voltage first. So I have it on pins 7 and 8 on this amplifier here. I have it set on DC voltage. Amplifier's turned on and we're plugged into the current sink. So let's turn it on and see what happens. So we're climbing up here. We're about 6.1. I think that's good enough for some testing purposes, but we may want to address that to get to a little bit closer to 6.2, 6.3. So I moved the leads around. I have it on the ground of the amplifier, and I also have the red lead right after the second filter cap. So that's pretty much the B+. That's going to be hitting the output transformers. So let's go ahead and turn it on and see how the B+ climbs. Almost 400 volts there. Now it's starting to warm up. I can see the current draw on here lining up. So it looks like the tubes are conducting. And we're at 353 volts. So that's pretty much what I calculated out to be. So that is the bias resistor there. So that is a 680 ohm 5 watt resistor. And we have one there and we have one there. So what we're going to do is we're going to install the multimeter across that, and then we're going to measure the voltage drop, and then we'll do our calculation for current and plate dissipation. And as the tubes warm up, it will start conducting. So you can see we have 16.7, 16.8. So let's go ahead and crunch some numbers here. I measured 16.8 volts at the cathode, and we know that the cathode resistor is 680 ohms. So we plug that into Ohm's law, 16.8 divided by 680, and that gives us 24.7 milliamps of current. So now we need to get the plate voltage. So I measure the plate voltage at 346 volts. And we have to subtract the two, the plate to the cathode, and that gives us 329.2 volts. And we put that into our power equation, 8.13 watts, and that's well under 10 watts, about 80%. So I've been listening to the amplifier here, it's been working pretty good, and then I was getting some weird voltages on one of the cathode resistor. As it turns out, one of the oil and film coupling capacitors was actually leaking DC, so I removed both of them, replaced them with something different, and now we're back in operating order again. So there are the new coupling capacitors. They are a little bit smaller than these, but they seem to work fine. And with the DC filament voltage, I managed to solve that as well. I had a 0.12 ohm in it, and I ended up installing a 0.2 ohm, and it goes right there. So now the filament voltage is exactly at 6.2 volts. Well, the amplifier has been on for about an hour now, playing some music, and what I like to do is take one of these infrared thermometers and start probing around in there and see how some of the components are reacting. So let's take a look at that cathode resistor there. So we'll turn it on and probe it, and we're about 22 degrees, so let's go right to the end, and it's about 37 degrees at the end. That seemed pretty reasonable. Let's do the power transformer, and it's about 30 degrees. So that's well within spec. So that's a good thing that you can do. So let's look at the layout here. We have our incoming AC to the fuse, switch, and pilot light. to the power transformer, out of the power transformer to the full wave bridge rectifier. We have our filter caps, we have the B plus coming out to the ammeter, back out of the ammeter to a B plus rail across the back here. Each output transformer is directly connected to that, out of the output transformer, and they each connect to the tube directly. For the input section, each input section has its own dropping resistor and their own filter cap to help better isolation. From the filter cap, it goes to the tubes. Out of the tube for the first section, it goes to the coupling caps, back to the power section, and then each power section has their own capacitor and cathode resistor mounted on a standoff over here. We have our output transformer coming out, output section there, and we have our input section here. Everything is grounded to a star ground right here. For the filament supply, it's mounted against this wall over here. We have our dropping resistor, and then it feeds the shielded cable to each tube. So that's pretty much it. Nice, clean, and simple. Well, I'm really happy the way this amplifier turned out. It far exceeded my expectations. My previous shop amp was an EL84 single-ended amp, and though not as loud, this seems to be way more dynamic and the bass seems to be a lot deeper. Now, you don't have to build a preamp like I did. You could just stick with a power amp and put a volume control and an input select right on this amp. Though this preamp does drive this a little bit harder, you don't need to. So as I mentioned, I'll put a link in the description below of the parts list and a schematic. And if you feel free to make something like this, I'd like to hear how you make out. Once again, thanks for watching, and we'll see you in the next video.